Now, our next question reads, the length of a rectangle is 8.3 centimeters and its width is 5.45 centimeters. Calculate at A, the relative error in the area of the rectangle, at B, the percentage error in the area of the rectangle. So this question was extracted from a topic called Approximation and Errors, which is a topic in Form 3 of our curriculum, the 844 curriculum. So we can first be able to come up with a rectangle, so that is question 2, and then you can be able to get the dimensions given in the question. So literally, this can be a sketch of a rectangle they are referring to. You'll be told that the rectangle is a length measuring 8.3 centimeters and our width measures 5.45 centimeters. So 5.45 centimeters. So this is our rectangle and its measurements are as follows. And we are told to get first the relative error. Relative error in calculating the area. So what are you supposed to do when you have been asked to calculate the relative error in calculating the area of this rectangle? The first thing you're supposed to note is this. What is the maximum length and the minimum length, and also what is our maximum width and the minimum width, in as far as the measurements given are as follows. Now look at this. We are going to do this. We know very well that if I take my length, and of course I'll treat this to be my actual length. So my actual length that I'm going to actually use is 8.3 centimeters. So it means an error of 0.1 can get made. Why? The value is given to one decimal place. So when the value is given to one decimal place, I can actually be able to take an error that gets made as 0.1. So 8.3 can have an estimated error of 0.1. Look at it. So if it was maybe 8.33, I would have taken an error of 0.01. So that if I have two decimal places, then the error has also picked two decimal places. If the length is to one decimal place, then the error also picks a value which is able to pick one decimal place. So one decimal place in the length, one decimal place in the error. Then I'll pick that error, which is 0.1, then I divide by 2. I'll be looking for something called absolute error. So an absolute error that you're going to have here is 0.05. Why? 0.1, the error that can get made, divided by 2, give us 0.05 as our absolute error. So that from this absolute error, we can get what we call the maximum length. Because if an error is made, then you can have a maximum value or a minimum value. I can either overestimate or underestimate or give the exact length. You get the point? So maximum length is going to be the actual length that I have plus the absolute error that can get made in the measurement. So that translates into 8.35 centimeters. So that is the maximum length that the one doing the measurement can actually be able to get, in case any overestimation is made in the measurement of that length. Let's go to something else. We are going to call the actual width. actual width. And before I can go to the actual width, I can also be able to get what we call the minimum length. So minimum length. Minimum length. So then how do I get the minimum length? Because we do expect an overestimation or an underestimation in the measurement of that length. So you can either have a higher value than 8.3 or a lower value than 8.3. So minimum length of this can actually get fixed. So we're going to have this, we shall say the actual length is 8.3 and the error that gets made is 0.05 in terms of absolute error. So the error has to actually get used in getting the maximum or the minimum in terms of the length to get obtained, but error to get made. So that translates into 8.25 centimeters. So that can be an estimation of the length to get considered. Now, let's go to something else called the actual width. The actual width is 5.45 centimeters. That's the actual width. But now we can decide to make an error also in measuring that width, and that error can translate into 0.01. Why? The width we have here is given to 2 decimal places. So the actual width is able to get seen having 2 decimal places. That translates into an error with also 2 decimal places. Look at that. So that now to get an absolute error, for me to get an absolute error, what am I going to do? I'm going to say 0.01 divided by 2 for me to get what you call an absolute error. So that translates into 0.005. That becomes our absolute error. That becomes our absolute error. That becomes our absolute error. Absolute error. So that from this absolute error and this actual width, you can get the maximum width and the minimum width. So you can come here and have maximum width. Maximum width. How do you get maximum width? I'm going to pick the initial or the actual width, which is actually 5.45. Then I add to this absolute error, which is 0.005. So that translates into 5.455 centimeters. That becomes our maximum width if an overestimation is done, or if an error is made positively in terms of having a bigger value than the actual value given in the question. Then the minimum width, you see, once you have a concept that is well rooted in as far as this area is concerned, you may not actually be able to follow all these procedures. Some steps can get skipped, and as long as you ensure that the most important areas are captured in the work you are going to give to this examiner. So minimum width is going to be 5.45, then minus 0.005. So it means once you have those actual lengths, first get the errors that can get made to a particular number of decimal places. Number 2, calculate or get the corresponding absolute errors. From those absolute errors and those actual lengths, you can be able to get the exact maximum length, the exact minimum length, the exact maximum width, and the exact minimum width. From there, you can proceed. Now, this gives us 5.445. Very good. Now, can we get actual area? Because we have the actual length and actual width. We have the maximum length and the maximum width. We have the minimum length and the minimum width. So that we can get the respective areas. So actual area. And because this is a rectangle, we are going to say length times width. So that translates into the actual length is 8.3 and the actual width is 5.45. So this gives us which area? Calculator. we're going to have 8.3 times 5.45. That gives us 45, okay, 0.235. That is should be centimeters squared. That's the actual area. Then the maximum area will be equal to again length times width. So that translates again into, so our maximum length, because we're going to use the maximum length, just write, we shall say maximum length multiplied by maximum width. So that gives us, so our maximum length is 8.35 times, our maximum width is 5.455. So that gives us, so 8.35 times 5.455, 45.54925. 54925 centimeters square. And lastly, we are going to call the minimum area. The minimum area. So minimum area should be equal to, we shall say, minimum length multiplied by minimum width. So our minimum length is 8.25 multiplied by our minimum width is 5.445. So that gives us, so we shall have 8.25 multiplied by 5.445. That gives us 44.92125 centimeters squared. So it's very evident, very clear, that this becomes our actual area if nothing is tempered. If an area is made, you can have the maximum area and the minimum area. Maximum bigger than the minimum. Okay, they were asking for the relative error. They were asking for the relative error in that case. So we shall say relative error in the calculation of this area of this rectangle should be equal to maximum, okay, minus minimum, okay, divided by 2. Maximum minus minimum divided by 2. And we say everything is divided by the actual area. So let's say maximum minus minimum divided by 2 over actual area. Or someone else can decide to say maximum minus actual, okay, plus actual. Let me just extend here. So maximum minus actual, write it. So maximum minus actual, okay. Then you can say plus actual minus minimum, okay. Then again everything is divided by what? Actual area. That can give what you call relative error. So someone can decide to say relative error is obtained by saying maximum area minus minimum area divided by 2 over actual area. But I can decide to say maximum area minus actual area plus actual area minus minimum area divided by actual area. That gives you what you call relative error. Let's see. Now, our maximum area is this. So 45, okay, 0.5495 minus minimum area is 44.92125. I divide this by 2, then I now divide everything by the actual area. And our actual area is 45.235. Let's see what it means. So we have 45.235 45.925 minus 44.92125. So this is divided by 2 and everything is divided by 45.235. So it gives us, so we have 45.54925 minus 44.92125. And divided by 2 is divided by 45.235. So I want you to give me the answer. So it will be 0.00694. So that becomes our relative error in getting the area of that rectangle. And you can as well be able to get your relative error in a different way. How? Someone can as well be able to decide and say maximum, okay, area, of course, minus minimum, okay, or someone can say maximum minus actual, then say plus actual minus minimum, then this is divided by what? By 2, then over actual area. So you can as well say, if you do not want to say relative error is maximum minus minimum divided by 2 over actual area, you can as well say maximum area minus actual area plus actual area minus minimum area divided by 2 then over actual area. What is our maximum area? 45.54925 minus our actual area 45.235. We shall say plus our actual area 45.235 minus our minimum is 44.92125. If this gets divided by what? By 2. Then further divide everything out of, or divide everything by actual area. We're going to get the same answer. So let's try and see. 45.54925 minus 45.235. That gives us 0.31425. We shall say plus, we shall say 45.235 minus 44.9125. So it give us 0.31375. This is divided by what? By 2, and everything out of actual area. Correct. So that it is going to give us which answer? We shall have this plus 0.31425. Then we divide this by 2, give us 0.3. Proceed to give us 0.314 divided by 45.235. This still gives you the same answer, 0.00694. So whichever way you want to actually do it, you still get the same answer. So to get the percentage area, in terms of what we call the percentage area getting the area, we're going to say percentage error is equals to relative error times 100. That translates into 0.00694 multiplied by 100, which gives you the result will be 0.694%. That comes your answer. 0.694. So 0.694%. That comes your answer. In terms of percentage error, you can get the area of that rectangle.